All right, welcome to our sixth video of our fifth unit of AP Chem. Oh, it says right there, that's awkward. This one's talking about calorimetry. So, while energy is always conserved, and thus a system will gain or lose exactly as much as the surroundings gain or lose, our temperature is not always conserved. Meaning, if I'm, holding a snowball and the snowball increases its temperature by 10 Kelvin, my hand may not decrease by 10 Kelvin. It may decrease by 1, if any at all, or more for that matter. So calorimetry really studies temperature changes, actually. So a transfer of energy, will not always raise the temperature of the substance gaining the energy by a significant amount. Meaning, yes, it will technically always raise the temperature. Temperature measures average kinetic energy, but your average may go from 10 Kelvin to 10.0001 Kelvin. Yes, it rose, but no one really cares. So, keep that in mind. The measurement of heat flow, and especially temperature changes, is called calorimetry. Metry referring to measurement, calorie referring to energy/heat. And it will constantly use a device called a calorimeter, which is a device to perform calorimetry, hence the name. So, we have a couple different types of calorimeters. A constant pressure calorimeter is a device that maintains constant pressure so that the heat flow can be easily tracked. Hence the name constant pressure. There are very elaborate calorimeters, but a very simple coffee cup calorimeter works sufficiently well enough that you're going to be using that in an upcoming lab. A coffee cup calorimeter consists of a solution of interest, which is placed inside a styrofoam coffee cup. That cup is then placed inside another styrofoam coffee cup. And as you're going to see soon, might as well continue the drawing. No, I'll draw it on the next slide, actually. The stopper is placed over the cups then to seal in the pressure. So we have a stopper. And then a thermometer and a glass stirrer, or at least something to kind of stir it. So we got thermometer and a stirry thingy. It's placed through the cork. This allows for the solution to be mixed, but the temperature to be read while still maintaining constant pressure. Very, very cheap, very easy to do, as long as you have all the stuff. And basically what you do is you let this thing react and you track the temperature change. Kind of a duh, but it works pretty well. So you have an example in your notes. I really don't know why this is there. Skip it. So a bomb calorimeter is a calorimeter that is used to most accurately study combustion reactions. So, and we're going to talk about a bomb calorimeter. And I lied. We're actually not going to talk about it, so we're just going to draw it first. Because apparently I don't talk about it here. So, a bomb calorimeter, you've got a giant, typically metal canister thing. Okay? That canister is typically filled with water. Inside that canister, you have a smaller, cute little canister. Okay? Inside that canister, you place your solution. Okay. We then take typically two kind of wires, stick them into that. We have a thermometer going in there. Typically, it's a digital thermometer. In case you want to know, we don't just wait for the mercury to rise. Mercury alloy, technically. And then we have a stirry bar thing. First off, the term bomb calorimeter, this is called a bomb. Okay? The outside solution, is it water? These are what we call the kind of ignition wires. We got a stirrer. And we have a thermometer. Oh, lastly, that is our solution. So basically what happens, you send a charge of electricity down to start this reaction. That starts going on. That then starts heating up this bomb, and typically we know exactly the material it's actually filled in. Thus, we actually know if it raises by so much Kelvin, we know how much energy is placed. Even more so, that will then start heating up the water. We track the stir is there to disperse the water around, but we know a lot about water, and so we can track exactly how much energy came in based on the actual temperature change of water. So that is a bomb calorimeter. Much more scientific and expensive than a coffee cup calorimeter, but typically works a lot more accurately. Not saying the coffee cup works bad, it's just this is typically like the higher standard, if you will. This is also necessary if you need to also keep in track of constant volume, because this thing will not flex, however a coffee cup can. And you've got kind of a lot of extra space in that coffee cup, depending on how much solution. This typically is just set and it's not going to be moving. Lastly, any bomb calorimeter, as I mentioned, we commonly surround the bomb with water, basically because we know water is what we call heat capacity very, very accurately. We'll talk about that shortly. But maybe we've already talked about it. That's kind of awkward that I don't remember. But we surround it with water because we really know a lot of detail about that. And thus, as energy is transferred through water, we can track exactly how much energy. There you go, though. That's our introduction to calorimetry. We have another video, Calorimetry Continued, where we basically practice calorimetry. So, thanks for watching.